Hello to everyone, this is Bharat. So today we'll discuss about the special kind of vectors and matrices in machine learning. So we have some set of vectors. Already we know what is called vector. So let us see. So here we have. So let us begin with matrices. So the first one is the diagonal matrix. So the diagonal matrix consists mostly of zeros and have non-zero entries only along the main diagonal. So in this example, we can observe here clearly. So the diagonal part, these all are non-zeros and the remaining all are the zeros. So these all types of matrices I hope you already learned at the uh, school level and so they need matrix also. So anyhow, as part of the machine learning, so we have to represent the data in terms of matrices or vectors or scalars. So we are discussing which part. So now let us see. So here you can observe some set of matrices. This is row matrix. So it is A equal to AJ 1 by n. So row by column. So you can hear this is the single row and single row matrix. So P equal to 1 minus 3 something. So and this is column matrix is a one type of matrix and null matrix it is a all zeros and singleton matrix is all uh, 4 7 p and these all are the singleton matrices. Horizontal matrix. So this is the two rows and four columns are there and this can be 2 by 4 column matrix. And here this is vertical matrix. The vertical matrix is of 1 2 3 4. So 4 rows and here 2 columns are there. 4 by 2 matrix, right? So similarly we have the special vector. So including this all type of matrix, we have identity matrix is there and square matrix is there and some of the matrices symmetry matrix, right? So these are the different kind of matrices. So they will be useful in the machine learning concept. So to represent our data. Okay. So now the confusion matrix is also there in the machine learning. The confusion matrix it is a type of square matrix as we already discussed square matrix. So this square matrix confusion matrix will be looking like this: true positive and false positive, false negative and true negative. So I hope you already know it. What is the purpose of confusion matrix printing? The, the confusion matrix it is used to evaluate the model, the performance of the model. So confusion matrix are useful for assessing the model accuracy, precision, recall, and other metrics. So you can see here example. So predicting the dog. So actual if some dog is there, dog picture is there, then if it detect it, your model is detected, it is a true, then it will be true positive. And if it is actually it is a dog, but the model is not detected properly, then it is called false negative. And it is a dog, uh, but it is not a dog, but it detected as dog, then it is false positive. And it is not a dog, but it is detected as um, predicted not dog, then it will be true negative. However, I hope we know. So these are some of the examples already. Uh, the who are studying the machine learning they can understand very easily. So however, the machine learning the matrices we have different type of matrices. We have these are the special kind of matrices. So now let us see the special vectors we have. So some of the special vectors like input vector, weight vector, bias vector, and that activation vector and attention vectors. So we know very well. So you can see here the definitions are given. The input vector represents the features or attributes of the input data. Each element of the input vector corresponds to specific feature, and the vector as whole represents a single data point. So and the vector, weight vector, it is like a parameter. Is useful in the during the training process. So so if you observe this diagram, so we can understand all the type of input vectors here, special kind of vectors. So this is the input vector x1, x2 and xn. So these are x1 and x2. So these all are input vectors are supplied as inputs to the model, right? So and so we know the weight carries the signal, right? So the weight vector is there in this weight vector. So some set of weights are available, w1, w2 and so on n, right? So these weights will be carried the signals. So if you want to identify the total output, so we know the formula yin equal to bias plus sigma I equal to 1 to n xi wi. So this input net input will be calculated or output will be calculated. So after supplying these all input values, so that's why these values are taken as vectors. And bias, so the bias vector will be represented like, so you'll see the bias vector. So bias vector can be x equal to, it is like a constant 1 comma x1 comma x2 comma x3, right? So this bias will be added in the training process to increase or decrease the net input. So to calculate the input net input or input to decrease or increase. So once it is identified, then we will go to the activation function. So this so that's why, as we mentioned that, so these are the set of special vectors: input vector, weight vector, bias vector, activation vector, attention vectors. So the activation vector is also useful beside, so it is used in the neural network. So once we have calculated the yin, after calculating the yin, so we'll have the formula, different type of activation functions we have. So one of the activation function we can take identity activation function or binary activation function. So we have some set of the type of activation functions. So based on this y input, or so the activation function, the value will be calculated, right? So for example, 1 if yin is greater than 0, right? And it will be 0 if yin is less than 0. So this is a type of a binary activation function, right? So I hope we already know this. So regarding this, these all activation, these all values will be uh, stored in the vector, and it is called activation vector activation, right? So and is all based on this only the final output will be calculated, and once the final output is calculated, that will be verified with the target value. If y equal to target, actual value and predicted value both are same, then the training process will be stopped. Otherwise, again the come back to changing of the weights, right? So this will happen until you get the proper input value, the expected value and the targeted value and actual value meets almost equal, right? This is the in this neural training process. So these all types of networks will be, these all types of vectors will be useful. So that is the intention about these different type of vectors we are having. And similarly, finally we have attention vectors. So this attention vector will be useful like, so if you see here, it will be useful in the sequence to sequence models, like in the natural language processing, and so LSTM, RNN, recurrent neural networks. So I need an English to French translation task. I love music to French. So the attention vector would assign higher weights to the music. So when the generating French translation, it shows the strong influence on the translation of the corresponding French word. So however, these are the different kind of special kind of vectors and the matrices. So that is about the today's class. So we'll meet in the next class with the new topic. Thank you all.